Hello everyone. Let's begin today's session with an interesting thought. Why does kerosene always float on top of water while mercury sinks right to the bottom of any container? The answer lies in a very useful concept, relative density. Relative density of a liquid is simply the ratio of its density to the density of water at 4 degrees Celsius. Mathematically, we write it as RD equals weight of a given volume of liquid divided by weight of the same volume of water. Since it is a ratio, relative density has no unit, it is just a pure number. This allows us to directly compare liquids on how heavy or light they are compared to water. Now, how do we measure this in practice? That's where Archimedes' principle comes in. You remember, any body immersed in a liquid displaces a volume of liquid equal to its own volume. So, instead of directly measuring the volume of liquid, we use displacement. This changes our equation to RD equals weight of liquid displaced by a body divided by weight of water displaced by the same body. This clever method ensures accuracy because we are using the same solid body to compare the two liquids. Let's see how this is done experimentally. Step 1. Take a solid body denser than both the liquid and water, but insoluble in them. Step 2. Weigh it in air. Let's call this W1. Step 3. Weigh the same body when immersed in the test liquid. This gives W2. Step 4. Weigh it again when immersed in water. This gives W3. Now substitute these into our formula. RD of the liquid equals open bracket W1 minus W2 close bracket divided by open bracket W1 minus W3 close bracket. Let's walk through why this works. Loss in weight of the body in liquid is equal to W minus W2. Loss in weight of the body in water is equal to W1 minus W3. According to Archimedes' principle, these losses correspond to the weights of displaced liquid and displaced water. So, the ratio of these two losses gives the relative density of the liquid. Simple, powerful, and elegant. Now let's solve a numerical problem to make this concrete. Suppose the weight of a body in air, W1, is 100 gram force. Its weight in liquid, W2, is 80 gram force. And in water, W3, it is 75 gram force. So, relative density of the liquid equals open bracket 100 minus 80 close bracket divided by open bracket 100 minus 75 close bracket. That equals 20 by 25, which simplifies to 0.8. This means the liquid is lighter than water because its relative density is less than 1. So, to summarize today's concept, relative density of a liquid tells us how heavy or light a liquid is compared to water. It can be measured using Archimedes' principle without ever needing to measure the liquid's volume. The working formula is RD equals open bracket W1 minus W2 close bracket divided by open bracket W1 minus W3 close bracket. This method is widely used in industries, chemistry labs, and quality control tests, from checking the purity of milk to identifying oils and industrial fluids. I hope this makes the concept crystal clear. See you in the next class with another fascinating application of Archimedes' principle.